In the previous lectures, we explained that for every communication to be established, we need a socket from each side. A socket would act as a endpoint representing that program that may be client or the server, and is a combination of an IP address and a port number. In this lecture, and we saw, for example, we said that using the browser would take care of everything for us, even using the higher level module request in the Python. It also take care of some things that you wouldn't have to manually create a socket. But in this lecture, we want to use the lowest level module in Python, which is socket. Socket is the base source in the most high level modules and libraries in the networking in Python. So in here we enter the Python shell in our terminal in Linux, and first of all we import socket, which is a built-in or a standard module in the Python, so we wouldn't have to install it. So we import socket, and if we want to create a socket, we use the name of the module and then the method of socket. Now we should enter different arguments. We could create a raw socket so that everything would be handled by ourselves in the raw socket. We should take care of everything, but in here I just want to create a socket, but some of the things I want the operating system to take care of those things. So for the first argument, I set socket af underscore inet in here, and for the second one I said socket dot sock underscore stream. Now what happens in here is that we have said that I want the operating system to take care of the IPv4 header and also the TCP header. So we know that when we want to send some data, for example HTTP data, the TCP in the transport layer, the TCP has to encapsulate the data, and in the internal layer the IPv4 header has to encapsulate the TCP packet, which includes the TCP header and the data itself. What you are doing in here is that we are saying that I want the operating system to add the related IPv4 header and also adds the related TCP header in the transport layer. Now when we hit enter, a socket would be created, but we want to just save it into a variable. Let's name this variable A1. Now A1 includes a socket that we could use it to be able to transmit and receive the data. One of the methods that we could use is the connect. Now we have created a socket, but we should use it to connect. You could notice in here that right now that we have created socket, it means that it has been bound to a port number, so it is using one of the active network interface card in my operating system, and also the operating system has assigned a port number to this socket. Now if we say a1.connect, connect method in the socket module could be used to connect to other devices. So if we say a1.connect, now connect takes one argument but as a tuple in here. So for the first argument we should provide the IP address that we want to be connected to. Now let's say that we want to connect to the google.com, but we don't have the IP address. So what we could use is to use another method in the socket module which converts the which does the domain name resolution or the DNS. The only thing that we have to say is to say socket get host by name. Now we feed it the URL of the website that we want to be connected to, which in this example is www.google.com in here. Now what would happen is that get host by name would resolve this domain name in here to the related IP address, and the first argument of this tuple in here would be the IP address. Now for the second one, we should feed it the port number that we want to be connected to on the server side. So we want to connect to the port number of 80 of the google.com web server. Now if we just hit enter in here, actually before we just hit enter, we want to open our Wireshark to see what would be going on. So we press Ctrl Shift and T to open another tab, and we type Wireshark and then the ampersand in here, we hit enter. So now it's running. This is our Wireshark. We want to listen on one of the active network interface card. ETH2 I think would be the active one in this case. So actually let me just check it. So we just type ifconfig in here, and ETH2 is the only one with the with some IPv4 address. So we open the Wireshark and start sniffing on the ETH2. Now in here we just hit enter to connect to google.com and port number 80 and see on the Wireshark what is going on. So we hit enter, it has been executed. We open the Wireshark. So as you see, first of all, let me actually just stop the capturing. So first of all, because of the get host by name that we have provided in here, the www.google.com should be resolved to the related IP address. So a DNS packet would be sent. This is my IP address, the IP address of my network interface card. You see the protocol is DNS. The destination in here is the DNS server of my network that I have provided. It is in my internet service provider DNS server. So I have sent a DNS packet. If we look at the domain name system in here, you see that a query has been sent. This query says that the name is www.google.com and I want the type A or the IPv4 address related to this name. Also, the class of this query is in, which means that the google.com is a host in the, is a domain, or google.com is a domain in the internet. So in the second packet, the DNS server has sent us with the required information. You see in here that the source is a DNS server and we are the destination. If you open the packet again, you see that in the queries it says that this is exactly what you have asked for, and this is the answer related to that, which says that 172.217.18.132 is the related IPv4 address of the google.com, and the length of it is 4 bytes and other kind of required information. Now this IP address would be replaced in this argument, in the first argument of this tuple in here. Now that we have the required information, using the connect method, we would send a packet to this address that we have received from the last packet. So in this packet, this is a TCP packet. If we look at the transmission control protocol, you see that the source port is this port number which the operating system has assigned for us the moment that we created the socket and we want to connect to it. After that, the destination port number is 80, which you see that we said that we want to connect to the port number 80 of this IP address. Now we send a SYN packet. If you look at the flags in here, it is a SYN packet. In a SYN packet, the only flag that is set is SYN. It means that we want to connect to you, google.com. Then it sends another packet to us, says a SYN and ACK. You see that both of these flags are set, and if we look, it says SYN ACK. It says, yes, I have received your SYN packet asking for a connection. I acknowledge it. Okay, let's establish a connection and a communication. Now the client would create another packet called an ACK packet. The only flag set in here is the acknowledgement flag, which says, okay, since you have agreed to establish a connection, I agree to. Now after that, the TCP connection would be established. Now both of these, client and server, they are ready to trade information and start the sending and receiving the packet. This is called a three-way TCP handshake, a three-way handshake, unlike the UDP, which we don't need to establish any connection before the communication. As you see, it has 3 ways. First, client asks the TCP, then TCP acknowledges the, first the client asks the server, then the server would acknowledge the communication. After that, client would say, okay, let's start sending and receiving the information. Now that we are ready to send and receive information, we are going to start sending HTTP data to our server. See you in the next lecture.